Alright, this is part 1 of a lesson that is reviewing Unit 4, which was called Extending the Number System. In this lesson we are going to, in this particular video, we're going to focus on the difference between rational and irrational numbers, and maybe we'll get into simplifying some expressions. But let's start with talking about number sets, rational numbers, irrational numbers. Alright, there are two main ways that we can think about the difference between rational numbers and irrational numbers. One way is that rational numbers are numbers that can be written as a fraction of integers, and irrational numbers are numbers that can't be written as a fraction of integers. By the way, integers are numbers like -3, -2, -1, 0, 1, 2, 3. Alright, so the integers do not include any decimals or fractions or anything like that. Alright, they're just these numbers, the numbers that you would count with, like 1, 2, 3, 4, 5, the negative versions of those numbers, and 0. Those are the integers. That's it. That's the whole list. So keep that in mind. So when we say rational numbers can be written as a fraction of integers, we're talking about a fraction that's made with only these numbers in the numerator and the denominator. So when you have a number like -2/3, is that going to be a rational number or an irrational number? Well, obviously this is going to be a rational number, because clearly it can be written as a fraction of integers. It is a fraction of integers already, 2/3, especially if you understand that -2/3 is the same thing as -2/3. Alright, now it's literally just a fraction of integers, so obviously it's rational. What about the number 5? Is that going to be rational or irrational? The number 5 is also going to be a rational number. The number 5 could easily be written as a fraction of integers if you understand that 5, if you understand that 5 would be equivalent to 5/1. Okay, so there. 5 could be written as a fraction of integers, 5/1. What about the number 0.3? Is that going to be rational or irrational? 0.3 is also going to be a rational number. 0.3 can be written as a fraction of integers. Back in elementary school, you should have learned about the place value system. And instead of just always saying 0.3, another way to think of this is by saying, oh, this is the tenths place. So 0.3 is the same thing as 3/10. Okay, so 0.3 equals 3/10. Okay, so there you can see that 0.3 can also be written as a fraction of integers. Now, if you didn't learn about the place value system, that didn't mean anything to you, so you might feel better if I looked at it in a calculator. If I do 0.3 in a calculator and toggle it, maybe now you'll be convinced that yes, 0.3 is the same thing as 3/10. Okay, so we've seen 3 different kinds of numbers that can all be seen as a fraction of integers. What else? What about the square root of 7? That's a number. Is that going to be rational or irrational? The square root of 7 is our first example of an irrational number. There's no way to write the square root of 7 as a fraction of integers. Now you might be thinking, based on, well, when we had 5 we just put 5/1 and that counted, it's a fraction. couldn't we just take the square root of 7 and write that as the square root of 7 and put it over 1? Alright, see, it's a fraction. Yeah, it's a fraction, but it's not a fraction of integers. Remember, integers are just like 1, 2, 3, 4, -1, -2, -3, -4, and so on, and 0. So the square root of the square root of 7 is not an integer, so this is not a fraction of integers. So that doesn't count. Okay. Also, if you put the square root of 7 in your calculator, just something to be aware of, right? If you try to simplify it or something, notice that we get this long decimal. And what you're going to learn is that square roots like this, these decimals just go on and on and on and on forever. They never end, and they never repeat. That's going to be important later. So square root of 7 is definitely an irrational number. What about pi? You're familiar with pi. Is pi going to be a rational number or an irrational number? Pi is an irrational number as well. Now, if you were thinking that pi is 3.14, you're close. The 3.14 would actually be a rational number. The problem is that pi is not equal to just 3.14. Pi starts out as 3.14, but then has all kinds of other crazy decimals after it. If we look at pi from the calculator, there's pi, but if we toggle it, it's 3.14159264, and just like that square root that we looked at, it goes on and on forever without repeating. So there's no way to write pi as a fraction of integers, so that makes it irrational. Alright, what about the square root of 9? Is that going to be rational or irrational? The square root of 9 is going to be a rational number. Why would that be? The square root of 7 was definitely irrational. It could not be written as a fraction of integers. Why is the square root of 9 rational? I'm sure you guessed it by now. The square root of 9 is equal to 3. Okay? And of course 3 is definitely rational because it could be written as 3 over 1. So because square root of 9 is just 3, that counts as a rational number. Should I put this as 3 over 1 just to make the point about... Yeah, alright. Square root of 9 could be written as 3 over 1. There you go, a fraction of integers. Okay, so that's one way to think about rational versus irrational. Rational numbers can be written as a fraction of integers. Irrational numbers cannot be. Now there's a second way to think about rational numbers versus irrational numbers. Rational numbers are always decimals that end or repeat. I should emphasize those letters, those words. End or repeat. Okay, for example, 0.3 ends. That's a decimal that ends. And sure enough, it turned out you could write it as a fraction. But the thing is, any decimal that either ends or repeats can be written as a fraction of integers. Alright? Obviously the number 5, that's just, 5.0. Boom. If 5, it ends. And sure enough, it's rational. What about the fraction negative 2/3? If we look at negative 2/3 in the calculator, Alright, let's toggle it so we can see it as a decimal. You can see that it is negative 0.6666666, and here the calculator rounded the last number to a 7, but really it continues 0.666 forever. So this is 0.6 repeating. Okay, so this fraction that we have is a decimal that repeats. So any decimal that either ends or repeats can be written as a fraction of integers and therefore is rational. Let's make up a repeating decimal and see if we can find the fraction that it equals. Let's say we just saw that 2/3 was 0.6 repeating. What if we had 0.7 repeating? So 0.777777777777777. Okay, my calculator's still doing it. I could toggle this, and the calculator is going to let me know that 0.7 repeating is equivalent to the fraction 7 over 9. Okay, so alright, that makes 0.7 repeating a rational number. Alright, but we don't have to check that every time. You can begin to trust me that if you see a repeating decimal, it's always going to be a rational number. Okay, and like we saw with the irrational numbers that we've mentioned so far, these irrational numbers are decimals that do not end or repeat. Alright, so remember when we looked at, for example, the square root of 7, whoa, I said the square root of 7, that gave us this decimal that goes on, does not end or repeat. And it was the same thing with pi. You get this decimal that goes on forever without ending or repeating. Alright, so let's finally get to the actual worksheet here and do these 10 problems. And we'll definitely stop because the video will be long enough by the time we just do this section right here. Well, we've already specifically talked about the number pi plenty. So in terms of rational or irrational, the number pi is definitely going to be irrational. Okay, it could not be written as a fraction of integers, and it's a decimal that does not end and does not repeat. Alright, how about the number 0.25? Is that going to be rational or irrational? 0.25 is definitely going to be rational. And it doesn't matter which way you look at it, immediately we saw that a decimal that ends is going to be rational. So 0.25 is a decimal that ends, so it'll be rational. Also, 0.25 can be written as a fraction as well. If we look at if we look at 0.25, alright, maybe you know that 0.25 is the same thing as 1/4. So either way you look at it, 0.25 is a rational number. What about the square root of 3? Okay, square root of 3 is definitely going to be irrational, just like the square root of 7. It can't be written as a fraction of integers, and if you looked at a decimal of it, the decimal would not end or repeat. Okay, so that is definitely going to be irrational. What about 3/10? Well, looking at the first way of thinking about rational numbers, numbers that can be written as a fraction of integers, 3/10 is a fraction of integers. So that definitely makes it rational. What about the square root of 16? why is the square root of 16 rational? Yeah, the square root of 16 is rational because if you look at the square root of 16, it's really just 4. And 4 can be written as a fraction of integers, 4 over 1. 4 is a decimal that ends. So either way you want to look at it, as a decimal that ends or a fraction of integers, square root of 16 is going to be a rational number. Let's see, what about the square root of 5 over 5? That is going to be irrational. This is a fraction, but it's not a fraction of integers. Alright, the square root of 5 is not an integer, and there's no way to write this as a fraction of integers. Also, if you looked at it in a calculator, you would see that the square root of 5 over 5, okay, you get one of these crazy decimals that runs off the calculator screen, and guess what? It goes forever without repeating. So this is definitely a decimal that does not end or repeat. It is going to be an irrational number. Alright, what about the number 0.52? And this little line over the top of it means 0.52 repeating. So 0.5252525252. What about that? That is going to be rational. Can you tell me why? Looking at the second way of looking at it, decimals that end or repeat. Repeating decimals are always rational. Now going back to the first way of looking at it, 0.52 repeating. If I do 0.525252, let me make sure I'm not missing any numbers, 525252, and if I just do this off my calculator screen a little bit and toggle it, turns out that's the same thing as 52/99. So you can see that in that way that it can be written as a fraction of integers, and that's another way of knowing that it is a rational number. What about number 8? Is this going to be rational or irrational? That's going to be irrational because of the square root of 5. Just like the square root of 3 is an irrational number, there's no way to take this and write it as a fraction of integers. And if I did 7 plus the square root of 5, you would see it's one of those crazy decimals that goes off the calculator screen, and you can trust that it will go on forever and does not repeat. Okay, what about this number? The cube root of 2 times the cube root of 4. I'm hoping to convince you that this is a rational number. Now, I know that the cube root of 2 times the cube root of 4, because the index is the same, alright, the root is the same, you can multiply these together. So I know that this is the same thing as the cube root of 8. And then I also know that the cube root of 8 is 2. Alright? Because 2 to the third power is 8. So the cube root of 8 is 2. Alright? So maybe, and of course 2 is a rational number. Now, if you don't understand anything that I just did about the cube root of 8, and if you couldn't have done that in your head, then you have another shot at it as long as you have a TI-30XS multiview and you know how to use it. You can type this expression in your calculator. If you want to do the cube root, you need to type the 3 first. And then see this little x root? If you type second caret, it turns it into the cube root. So what was it? The cube root of 2, and then times the cube root of 4. So again, I type the 3, and then I do second caret, and it becomes the cube root. So I've got the cube root of 2 times the cube root of 4. And like I said, that becomes 2, alright, which is clearly a rational number. Okay, what about the last one, number 10? Number 10 is definitely going to be irrational because of that square root of 2 in there. There's nothing we can do with that. That's not going to simplify or anything. That's going to be a decimal that goes on forever and does not repeat. Alright, if you weren't sure, you could use your calculator to give you a clue by typing it in. If we do 3 times 1 minus the square root of 2 and toggle it to see what happens, you see it doesn't simplify or anything. You just get this negative 1.2426 and it goes off the calculator, and believe me that it will go on and on forever without repeating, like all of these square root numbers do. Okay, so that is going to be irrational. Alright, it is a decimal that does not end or repeat, and there's no way that it could be written as a fraction of integers. There's no way to rewrite that. Alright, that is going to be the end of this lesson. I hope that you have come to understand the difference between rational numbers and irrational numbers. Alright, on the next video we will talk about simplifying exponential expressions. So I will see you on the next video.